Just making sure it wasn't zooming in too far. All right, so we've got our initial point right here, and we've got our terminal point over here. So we're gonna find our component form by finding the difference between them. So to get the component form of our vector, we need to find the change in our x's and the change in our y's. That's what the little triangle means, the delta, it's the change in. So, what are we gonna do?
-3 minus 3 and -5 minus -1.
Oh, careful, you've mixed and matched. You had the -3 and the 3. That's a y and an x. So for our x's, we need to take just our x pieces. So our -5 minus 3 and our -3 minus -1. So we got to find the change in the pieces. So what is the change in the x's? -5 minus -3. -8. What is our change in the y's? -2. So our component form of our vector is going to be -8, -2. Which means if I was to try and sketch this vector, what quadrant would it be in? 3. It would be down over here somewhere. So we know we're in quadrant 3. That's going to come in handy in a minute. So let's find our magnitude of this vector. That is this one right here. Which I know is like half underneath the close button up there. All right. It's very much the distance formula. So we're going to find the magnitude of our vector, which we get by taking the distance formula and combining it together with our vector. So we're basically going to take our -8 squared plus our -2 squared. So what do we get for the magnitude of our vector? There we go. It was gonna be like, no, and I can't figure out where. Yeah, square root of 68, which we could put in simplified radical form if we need it. We could get that into a decimal if we needed it. Depends on what we're being asked. I'm gonna say it'd be 2 squared root of 17. I don't have it as a decimal, but like, we could. That's what we use our magnitude. That's how we get our magnitude. That's just telling us how long the vector is. That tells us this distance. And then to get our angle, bless you, we do our arctangent, inverse tangent of y over x. So our y is at -2, our x is at -8. What is our theta going to wind up being? 0.04 degrees. Is that in quadrant 3? What quadrant's that one in? 1. How do I figure out the angle that gets us in quadrant 3? Because the one that we just found was this guy. Yeah. Because inverse tangent is going to give us something in quadrants 1 or 2. So to get our quadrant 3 angle, we need to add 180. So the actual measurement of our theta is going to be what?
194.05.
This guy is the theta for our vector, our angle, because it needs to be in quadrant 3. Okay. We can practice another one very much like it, just so we can see that. So very, very, very much like it. Same kind of vibe. We're going to find our component form. We're going to find our magnitude. We're going to find our angle. got our initial point at negative 3, 1, and our terminal point at 4, 5. So our component form, that's going to come from the change in our x's and the change in our y's. How do we set this one up? Mm-hmm. Yes, indeed it is. So our component form of our vector, the thing that makes this our component form, is now we can write it in our angled brackets. The change in our x's was 7. The change in our y's is 4. And that gives us our component form. That's this guy right here. This is our component form. We need to have the component form to be able to use either of these things. It has to be in the component form. Yes, dear?
Can we like switch it? Like switch the numbers? Like do negative 3 times 1.
We're always going to want to have our terminal point minus the initial point. Because vectors, it does matter the direction. So if they give you different letters, they would probably tell you which direction it is. So it should be initial point is the one we're subtracting. So it's always going to be B minus A at this point. But if we ever gave you like C and D, and it was Ray DC for some reason, then it would switch, but that'd be weird. It could happen, but it'd be weird. So let's do our magnitude. So the magnitude, we draw that with our double absolute values of our vector, which I didn't name it, but we could. We're going to use our formula. So this is our distance formula. It's our square root of our 7 squared plus our 4 squared. So what is the magnitude of our vector?
Square root of 65.
Square root of 65. So then to find our angle, our theta, we do our inverse tangent or our arc tangent of our y over x, 4 over 7. So what is our angle? 29.7 degrees. And our vector, should we be in quadrant 1, 2, 3, or 4? Quadrant 1. Are we in quadrant 1? Yay, no additional work needed. So we've got our component form, that's this guy. We've got our magnitude, that's this guy. We've got our angle, that's this guy.
So when do you get actual work if it's negative?
If it's in quadrant 3 or 4, basically. Because if we think about arctangent, when we do inverse tangent, that's when we're getting values in the top half because it matches with sine. Inverse tangent is going to give us something up here. So if we have a vector down in quadrant 4, we're going to wind up with an angle in quadrant 2 when we do our inverse tangent. Yeah. Tangent matches with sine. It's on the top. Because the places that tangent is undefined, sine over cosine, it's where cosine 0. I think my brain's stuck. Okay, so let's do one more, last one. And then we'll stop here for today, and we'll go back onto it tomorrow. Once we get our brain around the vectors, it's fine. But sometimes it's just the getting our brain wrapped around them. So, same vibe. Component form, magnitude, and angle. I was like,
8 minus negative 5.
Negative
2 minus negative 2.
So what is our component form going to be?
13 over 6. No.
We don't build it as a slope. It's very similar vibe. But we're going to have our 13.
6.
Come on, careful, watch your signs. 2.
Same thing, same
No.
I was gonna say,
Correct.
-2 minus -4 will give you a +2. So that's our component form. Find our magnitude. Mhm. Find our magnitude.
Square root.
You're right, but I'm giving over to. You have a calculator. Okay, so 13 squared
What?
169.
plus
I
4.
remember.
So our magnitude,
Wait, so they switch? So 13 times 13 is 169, and then 14 times 14 is 196.
Root 173.
root 173. And then find our angle. Mhm. Nope, that's when we need to use our inverse tangent.
Oh, we want to do
8.75.
8.75. And since we're in quadrant 1, we don't need to do anything extra to it. Okay?
Wait, so I have a question. What if it's like, because tangent what if it's in like quadrant 2?
I was gonna say that's when we'll have to deal with the addition. So if we get, say, because my brain is sticking right now. Sorry, give me a second. Yeah, because if we do like inverse tangent and we get a negative, saying it's in quadrant 4, that's when we would wind up with a quadrant 2 value because we'd have to add the 180. Yeah, because I was wrong on that. But it's 9 o'clock in the morning and my brain's a little gooey.
I was in the first semester. Maybe it's just because I wasn't locked in.
What, this class?
No,
No, just shut.
There we go.